Hello, today we're going to look at the special role of zero in factoring. So essentially over the last couple videos you guys have practiced all the different types of factorings that you may encounter. And now we have to actually use that skill in a specific manner. And so what we want to look at is problems that ask us to find the value of C and D. And so this first problem, what I notice is that C multiplied by D equals 0. And at the moment, we want to kind of look at possibilities that are there. So for example, I know that 2 times 0 would equal 0. I also know that 0 times 2 equals 0. But I could get more creative with the numbers I'm choosing. 1.5 times 0, or 0 times 1.5. I could go with fractions. I could say 17/15 times 0 would equal 0, or 0 times 17/15. Could have an irrational number like pi times 0, 3.1415, or 0 times pi. In each situation, I'll get a product of 0, but the list continues to go on. And part of the reason why it continues to go on is I don't actually know which number was 0. All I know is that there was a 0 as one of the factors. And so the way we break this down is that C equals 0 or D equals 0. Pause for a moment, think about it. Does this make sense? Write down a burning question if you have one. And then the next problem we'll get to changes a little bit. Now I'm grouping C minus 5 times D. But this time I see that it equals 2. So I go back to trying to figure out, well, what are my examples? How can I get to 2 when I'm multiplying two numbers? Well, I could have 2 times 1. I could have negative 2 times negative 1. I could have 1/2 times 4. I could have 1/4 times 8. I could have 200 times 1/100th. I could have 2 divided by pi times pi. What I want you to notice is there's nothing consistent about this. There's an infinite number of ways that I can multiply two numbers to get 2, which is in stark contrast to the example above. In each scenario, there was a 0. In this scenario, no numbers seem to be the same, whether reverse the order or not. So this has many solutions. And in fact is not useful to us as we solve. Change the problem slightly, and I notice I have the same exact factor pair, but now I set it equal to 0. And I go back to the idea, well, just up above, I know that if I have two numbers multiplying together to equal 0, that one or the other has to equal 0. Well, that's an interesting fact, which allows me to write that C minus 5 equals 0, or D must equal 0. When I continue solving that, I get C is equal to 5 because I added 5 to both sides, and D is equal to 0. We can just rewrite it so they're on the same line. And of course, you want to check your work. So if C equals 5, I'll get 5 minus 5 times D, which question mark is it 0? Well, 5 minus 5 is 0. 0 times D would be equal to 0. So in fact, it doesn't really matter what number D is. It can be any real number. But it's going to turn out that this product is equal to 0. The same can be said if you go the other direction. C minus 5, if D is 0, if I multiply this quantity by 0, 0 times C, no matter the value of C, is going to be 0. 5 times 0 we know is 0, so 0 equals 0, which is exactly what we want. So here's a moment to reflect. It says, reflect about what we have just seen. So suggest pausing it, give yourself a chance to write and think about what you've just seen in the role of 0 in factoring. Now you may want to check it with what I'm about to write. I noticed when a product equals 0, one of the factors, or both, must be equal to 0. It was a consistent value in each example in problem number 1, whereas there were many solutions to problem number 2 and no consistent values. Ooh. And now all we have to do is apply this to our last problem. And so right now, a lot of these expressions are already factored for you, and then the equation is set equal to 0, and we'll kind of develop that skill set. But if you think back to all the factoring that you've been doing, eventually you do get these factor pairs. And so essentially what I can do, what I just learned, is that one of the factors, so C minus 5 is one of the factors, or the other factor where D plus 3, it's one or the other must be equal to 0, or potentially both. So C must equal 5, or D must equal -3. And in each situation when that is true, let's just check it out. If C equals 5, that would be 5 minus 5 times D plus 3 equals 0. That's 0 times D plus 3. And so this quantity has to be equal to 0 since we're multiplying by 0. Looking at the other way, C minus 5 times -3 plus 3. Does that equal 0? C minus 5 times 0. And that quantity would be equal to 0 also. Take a moment, write down some of the vocabulary. I underlined some key words. Solidify your understanding. Put the zero product property in your own words. And come into class ready and prepared to factor and solve equations. Thank you.